Alright, in this video we're going to talk about how to classify triangles. So there are triangle types by side and then by angle. Okay, so there's three of each. So by side we have an equilateral, which has three equal sides, an isosceles triangle, which has two equal sides, and then a scalene triangle, which has no equal sides. And then we can also classify by angle. Okay. Now, if we classify by angle, the acute angle has three angles that are less than 90. Remember, the angles are acute when they're small, so they're less than 90. A right triangle has one 90-degree angle, which again is going to be depicted by a little square there. And then an obtuse triangle has one angle that's going to be greater than 90. Now, if you classify by a triangle, you can classify by one side and then one angle. So it could be like an equilateral acute triangle or a scalene right triangle. Okay, so we can have two names that are associated with these triangles. If we have three sides to a triangle, two of the sides has to be greater than the third. Okay? The trick, though, is that the two smaller, so smaller side plus smaller side, has to be greater than the bigger side. Okay, so that would be something like this. So we have a triangle here. We have 5, 6, and 8. My two smaller sides are 5 and 6. So we would take 5 plus 6, and it has to be bigger than 8. Well, 5 plus 6 is 11. So that means that this can be a triangle. Okay? So basically, what ends up happening is sometimes we have some sides of a triangle that don't work here. So for example, if we had something like 8, 2, and 2. Okay? If we add our two smaller sides, we have 2 plus 2, and that would need to be bigger than 8. Well, 2 plus 2 is 4. 4 is not bigger than 8. Okay? So basically what we have is we have this triangle here that does not, the corners don't match up. So it can't be a triangle if we don't have lengths that add up to be larger than that great side. Okay? The same thing goes for if they're equal. If we have a side length of 10, one is 5, and the other is 5. What ends up happening if we have 5 plus 5 greater than 10? Well, 10 is not greater than 10. So this also is not going to be a triangle, because if we have this side length of 10, then we have one side length of 5, and then the other side length of 5, what ends up happening is we don't have a triangle. We just have two lines that are just being on top of another. Okay? So we have to follow that rule that the two smaller sides need to be greater than the bigger side. Actually, all of the sides, if you add them up, are going to be greater than the third side, but we just need to check that the smaller ones are greater. Okay? So classifying triangles, again, we're going to use these rules. If we have c squared equals a squared plus b squared, okay, then the triangle is a right triangle. This is actually our Pythagorean theorem. All right? But we're just going to keep c squared on the left to avoid confusion when classifying. I'll show you why in a second. Okay, so again, if they're equal, it's a right triangle. It fits into Pythagorean's theorem. Okay, this is Pythagorean's theorem right here. A squared plus b squared equals c squared. However, if we have c squared, and that is going to be bigger than a squared plus b squared, then the triangle is obtuse. Okay? Greater than, obtuse means we have an angle that's greater than 90. So again, that's why we want to keep that c squared over to the left. And then if we have c squared is less than a squared plus b squared, by the way, that's not an equal to, that was just me underlining. Okay, so if it's less than, then we have an acute triangle. Okay? So using these rules, let's do some examples to show you what's going on here. All right, so first of all, we have to make sure that this is a triangle. So first determine if the three lengths could be a triangle. Well, again, take the two smaller. Which ones are the two smaller? 3 and 7. 3 plus 7 has to be greater than 9. 3 plus 7 is 10. 10 is greater than 9, so we do have a triangle. Okay? Now we need to classify further. So let's go ahead and plug it in. So we have c squared. Now remember, c is the biggest, okay, side. So we're going to plug 9 squared. And then I'm just going to put a circle here because we don't know if it's going to be equal, bigger than, or less than. 3 squared plus 7 squared. Okay, 9 squared is 81. 3 squared is 9. 7 squared is 49. Okay, so 81, and then if we add up 9 plus 49, we get 58. So in that circle, 81 is going to be bigger than 58. Okay, so if we go to our previous, right here, if c squared is bigger than a squared, we have an obtuse triangle. So in this one right here, this would be an obtuse triangle. Okay, so let's go ahead and do another example over here. So again, we have these three sides of a triangle. We have, to make sure that the two smaller is bigger than the larger, so we have 20 plus 21. Oops, is that bigger than 29? It is. Okay. Remember, 20 plus 21 is 41. That is bigger than 29. So we have a triangle. We're good here. So now again, we need to plug it into our formula. So we're trying to figure out if c squared, so 29 is c, because that's the biggest. So 29 squared, again, I'm going to put a circle there because we don't know if it's bigger than, equal, or smaller. 20 squared plus 21 squared. So if you put this in your calculator, okay, 29 squared is 841. And then again, you can always use the scientific Desmos calculator. This was in here from my last video. But, and you can type in 20 squared plus 21 squared. Okay, and we get 841, and then we have 29 squared. And that also equals 841. So they're actually going to be equal this time. Okay, so when they're equal, again, we go back to our rule. And when they're equal, it fits into Pythagorean's theorem. So this triangle would be a right triangle. Okay, so I'm going to do 2 more examples here. So here we have 4, 11, and 16. So again, the two smaller ones, 4 plus 11, that needs to be greater than 16. Well, 4 plus 11 is 15. 15 is not greater than 16. So that's it. We don't even have to move on. We are not bigger, or we are not a triangle at all. Okay. So let's look at this one over here. Okay, 17, 17, and 22. So again, we add up the two smaller. The two smallers are the 17. So 17 plus 17, is that bigger than 22? It is. 17 plus 17 is 34, so that's bigger than 22, so we're good there. Then again, we plug it into our formula. So 22 squared, put a big circle there, 17 squared plus 17 squared. Go to our calculator. So you have 17 squared plus 17 squared. And then we have 22 squared. Okay, so we're using these values to bring it up from our calculator. So 22 squared, when we plug that in, we got 484. And when we added this, we got 578. So this is actually a smaller than, which is fine. It's an acute triangle. Okay. And that right there is how we would classify. Oh, the one thing I just want to go over this one really quickly. If we add these together, I get 8 and 15. So 8 plus 15 is greater than 23. We're going to try to figure out number 6 real quick. Well, 8 plus 15 is 23. And I have students ask me all the time, are these? No, 23 is not greater than 23. So again, number 6 would not be a triangle. Okay? And that's how you would classify triangles.